A very warm welcome from our side here from Schlotau and Wauer to a new webcast. We are really happy that you joined us today.
The topic for today will be the new CITS library in Lisa in our logic editor, a product or an extension to our OMTC library that we have already teased in a past webcast, but which we will present now in detail and also as finished product, so to say, or at least a product that is now market ready. For those of you, the very few who have not heard of Schlotau and Wauer, we are a software development and traffic consultant engineering company of over 30 years of experience, founded in 1991 in Berlin. We have over 100 employees at 6 locations across Germany. So yeah, our two main activities are software development, the most known product probably Lisa, and also design of traffic infrastructure, mainly traffic lights and consultant services in transport engineering. So I just want to give a short introduction so we're all on the same page, what we're talking about here. What are we talking about when we're talking about CITS? CITS, communication between or communication in intelligent traffic management. If we look at the state of the art or state of practice, so to say, in Europe and most countries where we're active, microscopic control of traffic lights is usually handled by local detection or radio messages for public transport priority. And this is done by analog radio standards or by stationary fixed detection. So when we're looking at individual traffic, we are totally reliant on these fixed detections, and car-to-X communication or vehicle-to-X communication is there to bring us more information in the future. And there are certain international standards that have been developed and that are being implemented. We are kind of in the stage of putting projects into practice and fine-tuning these standards, and we will talk about what are the main kinds of messages that are being exchanged and how does the CITS library in Lisa support you with these. What we are always interested in optimizing the traffic. What can be achieved is we can do earlier stage requests because you have more information from further down the street. Optimizing our stage sequences will hopefully become easier. Dynamic green waves are easier to implement if you have more information about the platoons on the street. And of course, prioritization of public transport can also be enhanced. How does all that work? First of all, when we are talking about a CITS, a vehicle to X communication, there are two main ways of how to implement it. We can communicate directly via radio messages with a roadside unit, a new piece of hardware connected to the traffic light controller, or the same message standard can be transmitted via cloud approach or a central approach via the cloud or via a central system. So we either go the long way over the cloud or the direct way via radio messages to the roadside unit. For those of you maybe not so familiar with the OMTC approach, in a OMTC compliant controller that is based on a Lisa logic, we are always having our control logic that is using an OMTC open method of traffic control library of functions. This is usually used to plan and design a control logic like a software project, and Lisa is the software that is supporting you in using these functions. And that is why when we're talking about the ITS, we're talking about an extension of the methods of the control logic of the library of functions that we can use at that point. So what are these new functions supposed to do? They're supposed to give us access to those new communication channels. When you look at the status quo or the usual library, you have functions like give me the status of a detector, give me the last radio message that the bus has sent. And here we're now looking at new communication ways new communication channels between the intersection and the vehicle, which is map, of course, on the one hand, the topology of the intersection. So that is something that the intersection has to send to the vehicles in the vicinity of the intersection. And Lisa is capable of exporting this topology file that is then stored in the RSU and sent to the vehicles, something that we have also already presented in the past webcast. Another communication channel are the so-called SPAT messages, current signal state and timing. So we are sending the current signal states out to approaching vehicles. So a vehicle, by matching on the map, can identify which signal it is approaching, and we can also send a message how much green time is left, how much red time, also a prognosis about when will the signal state change. So far, information or positioning, information about the state of the current signal. So how can we influence a control? Where is there new information for us as a designer of a control? And this is coming in these message formats: CAM, cooperative awareness messages, and signal request messages. So CAM, mostly designed for individual traffic, can also be extended to emergency vehicles and can also send priority messages. Could be used, for example, for truck priority, stuff like that. And SREM, designed for public transport priority, can also be used for emergency vehicles. So you can see both of these standards are very capable. They have a very broad definition to kind of being able to implement all kinds of solution and not close the standard too much, so we are left out with something that is hindering us in designing something useful. And that is also has been for us, or is kind of a challenge to bring all that together in functions that the user can use, but we will see how we have managed that. So what do these new messages can offer to us, these detection via CAM or SREM? What is the added value, or could be the added value against usual detection? Yeah, of course, we can request a stage in advance. So the request to change from one stage to the other can come in advance, not limited by where the detector is. If you look at these traditional examples up here, you have the request for the vehicle at the stop line. So actually you have to wait the whole change. A stage transition is something, is the time that you're actually losing until you have green for the requested signal group. If the detector is in a certain distance, you can react a little bit quicker, but with a CAM message, you could basically process the request exactly in the moment when it occurs and plan ahead, and you don't have any time lost. This is for the request. On the other hand, gapping out a direction or a signal group that has green already, we are looking at the current way of doing it. As soon as our time gap criteria is met, we're actually gapping out, where we are not having any information about the platoon that is maybe still coming because there's a too big of a gap in here. So we're looking at maybe not ending a stage prematurely because we have more information now at hand. So kind of to sum it up, use cases: public transport, of course, enhancing the communication via SRAM. I will show what more information we can actually get from an SRAM now when we look at LISA. Also, for Germany at least, there is the reason that the analog frequencies for the current standard, and I think in the European Union, have the license for analog radio messages for public transport are ending. They should have ended in 2021. Now they're ending in 2028, and we have to find a way to replace them. We already talked about priority for emergency vehicles, and have talked about the advantages of detection via CAM messages against stationary detection. So what of all these information channels that we've talked about can we find in LISA, and how can we enhance them, or how does LISA support us? First of all, of course, there's the generation of map data in LISA. Maybe we can look at this in the software itself. As you might know, the generation of an intersection in LISA is asking the user to enter all the relevant lanes, all the relevant connections. And while doing so, the information that a map, the topology that the RSU or the intersection via the cloud is supposed to send to vehicles in the vicinity is basically already here. So all the information that this map needs, the user basically has already provided, and we have simply implemented an export. If I say simply, of course, there was a lot of back and forth to talk about those parts of the standard that were maybe not so well defined, or stuff that you really just see when you get into the practical side of things or start using it. So all this work and knowledge has gone into this export, and we now have the experience of having exported hundreds of intersections already with this tool. So that is there and it's part of Lisa anyways. And we're very proud that it's working. And yeah, as you can see, we are now having these lane attributes here on the left side, like at CMap, and you have full control over the data that you're exporting there. So that is one of the communication channels that we talked about. But of course, this presentation is named CITS library. So where do we find this? Maybe for some of you from the international market to give just a short overview what Lisa is actually doing. If you are familiar with Lisa, you will know that the user here has full control over the traffic actuated control algorithms that the user defines. He is using a library of controller functions, usually the OML functions. This standard library is coming with the Lisa XL package out of the box. So this can work with all OMTC capable controllers. The CITS functions are an additional library that we're offering. So I have included it here in my project. And as users of Lisa are used to, we can access this online help where we have all these messages or all these functions with their definitions, with their in and out values, and a proper documentation. So if you're familiar with this, you will see that they are also divided by certain categories. This helps the user to find its way around the functions because, yeah, as you can see, there are almost 200 or over 200 controller functions, and the categories help you to find your way around. So we have 4 new categories. One of is CITS SSM, one is SRAM, CAM, and map. So, for example, with the map functions, you can, for example, access the number of lanes in your project, ask for the attributes. So, for example, if you want to know a lane attribute, there's this function map lane attribute. You are specifying the lane and then you're asking for the attributes. So the challenge here was that, as I said, it's a broad standard. It is designed to work with all future or find solutions for all future problems in traffic actuated controls. So we have included all the most important attributes that are defined in the standard. You will find that not all of them are here. This is based on our experience of the last 3 to 4 years in all these pilot projects. What is really essential, what is used by all of the cities that participated in these projects. We will, of course, extend these functions in the future as well. But this is, let's say, the first step in giving our users the access to all necessary information that comes over this new interface. Yeah, maybe to explain a little bit more about our approach here. So what I've showed you before was the logic editor where you have these new functions at hand. And then, of course, and that is probably the most important part, is that we now can also test and simulate this control in our Lisa test site. As you know, we have always had the possibility to run a virtual controller. And now accompanying that, we are also running a virtual RSU. So the roadside unit is also virtualized, and we are simulating the communication between the tools, if you want to put it that way, and to give the user a visual feedback about what is happening. We have down here in the where you usually have your events, a new tab that is called CITS. And this is showing the user the current vehicles that are in the what we call the vehicle buffer. So I don't want to get too technical, but the short version of this is, of course, to kind of make it easier for the user or for a control in general to go through all the messages that are flying around. You have, if you imagine, like theoretically, all the cars in the vicinity of the intersection or even in the wider area of the intersection may send CAM messages. They may send SRM messages if they're a PT vehicle. So these messages are not all directed towards this intersection. They are usually meant for a certain intersection, be it that the intersection where the current vehicle is approaching and it's matched to the map, or be it if it's a request messages, an SRM, then it's a message specifically for one intersection. But of course, the RSU will first receive all of these messages and has to filter them in a certain way. And the result of this filter is what we call the vehicle buffer, which is showing all the messages that are relevant for the current intersection. So when I start a simulation here, I have it a bit simplified, so we're only seeing one direction. If you look at the cars approaching, as soon as they are on the lane that belongs to the intersection, then they are here registered in the vehicle buffer, and now we can access all this information via the CAM attribute message. So asking for a vehicle ID, asking on which lane the vehicle is currently registered on, and so on. So there is some matching going on in the background in the RSU, but we don't, as a user, we don't have to worry about that. On the other hand, so this, as you can see, our CAM messages, they're automatically generated by the vehicles in this network. We can set a certain penetration rate. We were saying, okay, it might not be realistic that 100% of the vehicles are actually sending CAM messages, so we can change this value in increments of 5% and then see how does our control behave if we don't have all the information from all the vehicles. So if I apply this, then it will become instantly clear. Now I have much less messages here in my vehicle buffer, although I still have this big number of vehicles, which also leads to the answer of a question that nobody has asked yet. Of course, with this method and with these tools, I can have a control that is using both static detectors and CAM messages, because in my logic, it is just a different function. I can get the information from the static detector and as well from the CAM messages, and then do something that is taking into account both types of information, which is, I think, a pretty cool feature. If you have been using these constantly, then you know that these CAM messages have already been around since Lisa 8.0. The new feature in 8.1 is that we also included now the SRAM messages, and those currently can be entered by right-clicking, and you simply say sending an SRAM. And here you can predefine a list, long as you might choose, and then define the content of the SRAM message, request ID, estimated time of arrival. This is, of course, the big difference between analog telegrams and SRAM. The public transport vehicle is calculating its own estimated time of arrival, sending it to the intersection, and also updating it by itself. So we don't have to go through all that hassle anymore and calculate these times. And so usually the vehicle itself will have more information about where it actually is on the trajectory. And also in this system, it is part of the system that we are supposed to answer with an SSEM. So when the intersection or with a CAM messages, with a CAM message, which would also be a possibility, a user of the German webcast has pointed me to that information. There are several ways of confirming that. So if there is not a confirmation for the request, or that the request has been notified in the control, then the vehicle might send the request again, because it does notice that the intersection has not yet reacted to that, which in the current system is usually a big problem. If there is a radio message, a radio telegram about a bus approaching, and it is not received, then there is no way of correcting that. There is just one radio message at a certain point in time, and if it's not repeated, then this bus is simply not prioritized. Yeah, maybe just to show an example, a very simple example here of how these functions could work. This is just a function of where I have been experimenting a little bit. So you could ask for all the vehicles, or do an iteration over all vehicles that are in the vicinity of the intersection, and then ask for those which are in a certain approach and count them, for example. So you would always know from which approach do I have the most traffic right now. Or as for SRAM messages, yeah, simply ask the ETA, ask the time step. That is something that we can maybe look at here in our control. This is where here I'm asking if there is an SRAM being sent, and if I hit on send, then we are seeing now the estimated time of arrival is in 25 seconds, so it's milliseconds, and there is a time step. And with this information, I can now set up a priority logic inside of Lisa. Maybe I can reference to some projects before we come to the end. As we said, we have implemented these functions in several projects now in Germany, and the most important ones here, to name a few, login project in Hanover, where we do PT priority via SRAM messages, BD move in Hamburg, also SRAM messages, although they're processed via the central. As you remember, there are two ways of doing it, or you can either choose to send them via the central or via the RSU. Komoot Next in Düsseldorf, prioritization of emergency vehicles, in this case via CAM messages. And yeah, to name a few of our own services that we are offering, SPAT prognosis, something I have not showed in detail, but which is basically our own approach to having a prognosis for the signal phase and timing, which is using the input data of the controller to learn and to have an AI learning algorithm making more sophisticated prognosis for the next signal phase, and also CITS quality analysis, where we are offering cities to actually check their map data if it is correctly routed in reality.
Thanks a lot for joining us today. And as always, we are at your service if you have further questions. Please contact us at service@schlotauer.de if you have any technical questions, or if you want a quote, an offer, have any sales-related questions, then please contact us at lisa@schlotauer.de. Thanks and have a nice day.